rate of the height? The rate of the rate being positive, which means the rate of the height changing, increasing. How many of you guys thought, before you graded it, that the answer would be 0 to 12? Okay. How many of you guys just didn't have any clue? Okay. I'm not sure what the others of you guys thought. Never? Oh, the height increasing being constant. Okay. What is constant in the problem? dV/dt, good. The water is flowing in at a constant rate. But what's true about the tank that makes it so that dH/dt is not constant? The shape. The shape. The surface area of the water is changing. True? Down here, the surface area is small. And what's happening up until you get through halfway of the tank? What's happening to the surface of the water? The surface area is increasing. So if the surface area is increasing, that means the water, the dV/dt that's flowing in, is having to cover more and more and more and more and more. So if it's having to cover more and more and more, what do you think is going on with the dH/dt? As it has to cover more, is the height increasing faster or slower? Why slower? Why smaller? More surface area needing to be covered, so the volume is being used up more and more and more, so the height is going slower and slower. But what happens once it gets halfway through the tank? How many of you guys have filled up a water bottle and right there towards the end, whoosh, when is the height, the rate of the height increasing, aka the height increasing faster from 4 to 12? The height is increasing, but the rate at which the height is changing is because does that make sense? Yeah. No, it's okay, but I didn't do it in as many words. So the height is like the water's going up the whole time. It's not the question. It's how fast the height is changing. So it's going up slower, 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 faster, 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 faster. All because of the shape of the tank. Ironically, not because, huh? It's more logic. Yeah. But what if the tank size was a rectangular solid? Constant. Good. Right. Never increasing, never decreasing. The rate of the height changing. Right? What if it was a cone, an inverted cone? The height would always be increasing, but dH/dt would always be decreasing because what's always happening to the surface? Inverted. If it was a regular cone, then it would be always, the rate of the height would always be increasing. Yeah, I don't know what you would like. Was there anything? Like a, oh, my sister would kill me. I can't think of it. The in chem, yeah. The flasks, right? Those ones would be like normal cones. I mean, not perfectly, but close. Although it'd be constant at the very top because the constant, right? Isn't it like a little cylinder there at the top? Anyway. Cylinder. Wait. Sorry, I meant to scroll. I'm sorry. Okay, 24 to 30 or 24 to 26. 26. 24. 25? Am I here 24? No? 24? 24, what's going on? We have 3 quarter circles. Do you guys see them? We have a quarter circle there, and a quarter circle there. Oh, it's the same. And then we have a quarter circle there, which is equivalent from the integral or of the integral from 0 to 2 of f of x dx. F of x dx. Why is number 1 a yes? What's true about the 2 areas are the same. So if you go the entire region, half of that, right, the symmetry, half of that will be 0 to 2. Yep, so 1's true. How about 2? What's true about the bounds that we need to consider before we ever look up there? They're backwards. So we need to think going from 2 to 4, but with a negative, right? From 2 to 4, it's the same thing because the circle has the exact same radius, right? If it was a different shape, it wouldn't really matter. It'd be different. But since the circle has the exact same radius, I'm talking about the exact same area, but opposite. I got that. True, true. How about number 3? Why false? Good, it's 0 because I have the positive and the negative, which will cancel out. Half of that, no. I would need value, then I'd be good. Justin.
I ended up saying that only 1 is true because if you look at the second part from 2 to 4, it looks like it goes down to -2, but the first part only goes to like 1.5. So like wouldn't their areas be different then?
You guys can see it more precisely than I can. Does the 4, I felt like the 4 hit earlier. But you would need a straight edge. Do you have a straight edge, like a ID card or something? It looked like the 4 hit, like it kept going past 4. But I see what you're saying based on the picture. It was an imprecise picture. I think the 4 hits at the 1.5 also. I think it was a mistake in how, this is Barron's, not College Board, right? College Board has a lot more editors. I think they would have said 3 equivalent quarter circles in the AP. But I agree with you, the question could have been better. Yeah. So based on your logic, true, but based on what they intended. Okay, sorry, did anybody want 25? I didn't hear the, no, 26? Yeah, I thought I heard that. Perpendicular. Okay. You guys see cross section, right? Not necessarily pi r squared, even though we have a semicircle. First quadrant region bounded by the 4th root of something gross. What should you guys be pondering if worst comes to worst? Because who has the 4th root of 4 minus 2x memorized? Nobody, right? Okay, so what could you do to quickly visualize, just to get an idea? First quadrant, plug in 0. Isn't that going to end up being, I don't know, something positive? Plug in 1. Isn't that going to be something, I don't know, less than? Plug in 2. Isn't that 0? Do I know for sure? I don't know if it's concave down, concave up. I'm not going to go do analysis on it. But what do I have basically? Some sort of positive region. I'm not going to tell you concavity, but some sort of positive region. Okay. What do I know about the cross sections? I know it goes up to 2, starting at 0. And I know that I am slicing it perpendicular to the x-axis, which means dx or dy? Yeah, my thickness is going to be dx. Good. Perpendicular when you slice it. Okay. Isn't top minus bottom going to be my diameter? That's why a lot of people miss it. Top minus bottom is my diameter. So when I go plugging in, using my pi and using my 0 to 2 and using my semicircle, which has a 1/2, when I do my r, I need top minus bottom to be divided by 2. But it's not 1/4. 1/4 would be the weird, awkward, like this kind of slice. The whole semicircular slice. One-fourth. I mean, if you thought of the radius is cut in half and then squared being 1/4 and 1/4 and 1/2 is winning. You remember this last year when we were doing this, you got a little behind in this. I think you started memorizing tricks, and one of the tricks might have been to get the pi over 8 because we talked about semicircles. Might have been where your brain was going. But there were quarter circles. I mean, that is a thing. That has been a thing. In quarter circles, you would have a 1/4 pi r squared, but r would actually be the top minus bottom if it was a quarter circle being fit in, being the cross sections. So it could have been a quarter circle, but it's not. It's a semicircle. Just think top minus bottom is diameter cut in half. Justin, we good? Okay. We did say 26, but the nice thing about 26 is what do you guys see in the wording? But the problem is, isn't there an average value that requires, let me put it this way. Isn't there an average that requires a slope and an average that requires an integral? So which one's which? The value is the integral. So I need 1 over b minus a, the integral from a to b of f of x dx. Could you solve this by hand? Or? Not in 26, I don't think. Not until like 28, or well, maybe, I don't know, sorry, how'd they split it? Was it a calculator problem? No. Oh, I didn't think so. Absolute value of x's derivative is absolute value of x over x. Don't you know who this guy is? Aren't you just moving him up 1, 2, 3? Isn't it just a geometric figure that you could just find the area of? So couldn't you just go -2, do a trapezoid, and then do 4 and do a trapezoid? Or couldn't you be snazzy and do like a rectangle and then do 2 triangles? I don't know which one's easier. Yeah, I thought the rectangle, right? So you'd have a base of 6 and then a height of 3. So 6 and 3 would be 18. So I have 1 over 6. What else do I have? I have a base height of 5. No, a base of 2 and a height of 2. So that'd be 1/2, 2 times 2. Then I'd have 1/2. Base would be 4 and a height would be... Oh, duh. Why am I making this hard? 4 times 4? Oh, sorry. I'm adding my rectangle plus my triangle plus my triangle. I'm doing geometry. So I end with 18 plus 2 is 20, and 20 plus 8 is 28, and 28 over 6 is, something gross. 4 2/3. Dun, 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 dun. I don't know, with absolute value of x in an integral, I just think geometry is easier, but you could, you know how, split the bounds at 0. So you would go from -2 to 0 and 0 to 4, and then you'd do absolute value of both with 3 plus x. It could be. Could be. I think I would make more mistakes the other way, but yeah, either way. Shoop, shoop. All right, what do we got? 27, 28, anything? Oh, we can't do 27. 28, we okay on? Okay. Now calculators are allowed. I heard lots of 30s. 30, 32, 33. Okay, 30. Let's just start there. Why do I know that 30 can't be A? A linear second derivative would be 0, right? First derivative is a constant, second derivative is, okay. Quadratic. How do I know that this one's false? Derivative of like 3x squared would be 6x. That doesn't work. Cubic. Oh, that could be changing. 4th degree exponential. Well, I would think, well, all right, as you go from -1 to 0, 2 to 3, it looked linear. Well, you never know exactly what's going on in between points in the table. Right? But that shouldn't be enough to like cancel it out. The linear does actually help. But another thing is if you took the second derivative of a cubic, wouldn't that be a linear function, which could be positive, could be negative? But if you took the second derivative of a 4th degree, isn't that a squared, which is always positive? So I would cancel out A, cancel out B, cancel out D, because I have negative or positive. And exponential functions are always positive. Oh, forget him. C is the final. I said that very confidently, but I won't lie. A little part of me was like, what if I'm wrong? It's C. I was just being honest. Huh? In general with tables, like forget this one. This one's weird. In general with tables, thinking of it that way gives you like a basis, but you can't ever prove anything with that. Yeah, you were thinking like go back 1, go back 2. Yeah. No, that's not totally bad. Just in general, they're using tables in ways that if you say like what's happening is always happening, you're going to get in trouble. In FRQs. Yeah, because remember in FRQs, if you try to prove something being like, oh, look, it's increasing. Or there's only, and you have to always think about the in-betweens being unknown. So I'm thinking more free response, watch out, but multiple choice in general, you'll be okay. We had a lot of them. Sorry, 32 was one. Was there another one?
Yeah, 33.
Okay. 32, cup of coffee placed on the table. DHDT, sorry, that was an FRQ. DHDT is equal to... Does anybody else see logistic growth?
Yeah.
Oh my gosh.
And then you set up, yeah.
Right?
I just tried to say
Wait, why would coffee cooling be logistic growth?
water eventually flatten out at the temperature of the room.
Because you have a limiting constant of the room temperature. Yeah. What's it say though? What will be its temperature 10 minutes later? Oh, you would have to integrate separation of variables. Is it possible? Yeah.
Because I tried to integrate, but I couldn't remember H because like my bounds. Because like since H is temperature, it wouldn't be time.
Oh no,
I didn't think
Well, yeah, but I was saying like if you were integrating by hand, you could. Didn't think of it later. Right?
yeah, I have to actually integrate. It didn't work when I tried to integrate.
Okay. Good. It says the coffee is initially 120 degrees. That would be the H, the temperature, right? So H is 120 when T is 0. 0 would be 1 C, C plus 70 minus 70, 50. So then plug in 10. So you could have done it that way. Or the other way. Did anybody get logistic to work?
No.
Oh.
I tried to do this integration by net change, but I couldn't figure out bounds.
I think I would have pulled out the negative, right? Because then you would have had 0.05 and you would have had 70 L minus Y, which is what I want.
Because H is temperature.
And I would get lice minus licked. Ooh, it's not logistic. Why not? The limiting by the room temperature does make sense, but cooling logistic always goes up. It never goes down. I mean, it does go down, but it's not going to be a logistic curve. Why isn't it logistic? It's so close. They did that on purpose. That's mean. K, Y times L minus Y. There's no H. Isn't it KY times L minus Y? Yeah. There's no H in front. Meanies. So what's the only way to do it? That way. Yeah. Because your initial was 100 and... Well, the definite integral...
I couldn't give lower bounds because I had the 120, but then they still 5. That's the thing I'm trying to figure out.
Well, the problem is you have to integrate both sides. Right now you can't integrate it with any bounds because it's with dt, so it'd be illegal to integrate as is. Does that make sense? So you'd have to do separation of variables and to do a definite integral with... No, integration does not change, doesn't work. Because of the orientation or the difficulty level of the differential equation. Okay. Blech. Sorry, not logistic growth, but do you see? I totally got tricked too. Number 33. rate. That's the derivative.
Yeah, that's the derivative, and then in the work it goes on to like set the same thing up. So put 4,000 as C, but they kept the derivative, and then they said it was.
Why? It's exponential. What are the integrals of exponential? Exponential. So when you go to integrate, do they not show the integration work? That's mean. You could do like dy is equal to 320 e to the 0.08 t dt. You would end up with 320 over 0.08, right? Because your u would be that, du would be that, and divide it. Yeah, plus c. And then you would end up plugging when t. Oh, sorry. U is equal to 0.08. Oh, it's a calculator problem. Lo siento. Just kidding. After 10 years, you could do f of 10 is equal to f of 0 plus the integral from 0 to 10 of f prime of t dt. Just kidding. Sorry, Deba. Yeah. Does that make sense? Integration does not change.
Wow, I did that.
I'm sorry. Sorry, where else are we going? Anything up to the 40s? Graph of a first derivative, yeah? Well, graph of velocity.
Oh, I did not know how to do that.
Pause. Speed. Absolute value. So all of this needs to flip up because it's velocity. So we're looking for the maximum displacement, I guess, of the velocity rates. So therefore, the absolute max is right here, 8.
You know the answer is
6. Yeah.
6.
Whoa.
No, the answer's 8.
No, the answer is 6. No, it's 6.
It's 8.
Because I chose 6.
No, the answer's 8.
No, it's not. On the answer key it says 6.
Wait.
Oh, okay.
Is it one of those that skips?
The handwritten answer key was wrong.
Oh, what is with these keys? Dang, are you serious, Issa? Hannah, I'm sorry.
I put 8, and I was like, why is it 6?
Yeah, no, you're totally right. I am so sorry. What was that, 30 what?
35 and 36.
Oh, it's not even the same question.
Yeah, that's what I saw yesterday too.
They did it in the wrong order. What is 35? It's a sequence that they're doing. I don't even know what 35 is. Yeah, they're doing some magical something else problem. Yeah, 35 and 36 are off. Dang. But then 37's right. Anyway, Hannah, you're right. It's 8. So then does 36 make sense too? So what happens whenever velocity is negative? The particle is moving to the left because it's negative displacement. So it's moving to the left this area and then right this area. Yeah? So what we're asking is, hey, does the positive overtake the negative to let it return to the origin? Because it went back and now it's coming this direction. Just from like eyeballing it, doesn't that area look at least that, if not bigger? Well, I was saying it looks like it, but then we have to actually solve it, true? So then we have a base of 2 and a height of 1, that's 2, and then 2.5 is this, so it goes left 2.5 from an original. Oh, my bad. Sorry. It's at the origin here. I was thinking it started at the origin. I didn't look to see its initial position. So right here, so it was going, here's the origin, according to the model. It started somewhere here, because after 3 seconds of it going left, it hit the origin. Then it goes, sorry, you guys are right. Going left? No. I was right. Hits the origin. There we go. Then it starts going positively, so it starts going away. Then it changes direction. Okay. So from the origin, it goes of 1, 2, 3, height of 2. So that's 6 cut in half. That's 3. So it goes right 3 from the origin. I need to figure out where it goes left 3. And that's going to occur 1, 2, somewhere in between 7 and 8, right? Yeah. Yeah.
I have a question about 35. I kind of use like grid logic, so I just want to say.
Mm-hmm.
I just like assume I was the same sign.
Thinking of the speed function, trying to find a relative max, right? Speed increasing, speed decreasing. That'd be okay if there was only one max. Just be careful. In another situation, you might find a max that's not somewhere else.
I was just okay. I was just looking for like the longest piece, so that
Oh.
would be the greatest speed. So like from 5 to 8, there's like a really long piece of speed increasing. So I just assumed that was the greatest speed. So that's what that works, right?
It works for a relative, and the distance, in this example, works for the absolute. I would just think it might be a little dangerous in another example that would contain the speed with multiple maximums. Does that make sense? You weren't supposed to do 37. Okay, 41. You guys can come back if there's one before that. We have a definition, a formula for arc length, yeah? Do you see how they gave us the answer and we're supposed to kind of figure out the question? Right? So they said, oh, hey, this is arc length, so figure this out. Who's the curve? What's the definition, or I should say, what's the formula for arc length? Did we say S or L or S? Okay. Let's see. My A to B. See, 9 over X. Ooh. So couldn't I say my F prime of X must have been 3 over X? So I'm looking for who was squared. Does that make sense? So I can take 9 over X squared and be like, oh, square root that, because it was the derivative squared, so 3 over X is my original function. And then you can integrate that, yeah, and you would end up with y is equal to 3 of absolute value of x plus c, which, I mean, if you were going fast, I would just choose A. They technically give us, one end of the arc is at the point 1, 2. They give us 1, so you could plug in 1 and plug in 2. ln of 1 is 0, so c has to equal 2. But there was nothing else even similar. But it was me decomposing the formula, kind of. Yeah. That's kind of algebraic. I like that one. Because if you knew the formula, you just had to kind of be like, oh, let's compare, and then let's go ahead and pull out. And that's a good question. U sub, yeah?
Yeah. So when I did it, it was like kind of on crack, right? But then I did it, and why would it be B instead of A?
You got A2 ready? It's nasty. I mean, it's nice because they tell you the U sub.
Oh, is that why? Is that squared?
I'm forgetting my bounds right now, right? Because those are x bounds. Aryan, see it? Because otherwise it would have been like, but if you realize that is your U, then you can go ahead and throw in. Now, there is some work still to be done. Oh, you don't even have to solve it. Oh, okay. And then the bounds you didn't even have to worry about. Oh, yeah, but you guys should have known it wouldn't be. Could have plugged in 6 and plugged in 3 and gotten U bounds. Riley, that's good. You guys want something else around here? You guys know that's F squared, not F double prime, right? If there's little parentheses, it would be F double prime. But they never really show the 2. They do the 3 or the 4 or the 5 in those little parentheses for the 3rd and 4th and 5th derivative. But that's just F squared. That could have made all the difference. Because then 2F prime. Yeah, because of the d squared over dx squared. How'd you get that right? Really? Because then you'd have to do product rule. Second, d first, plus first. Oh, no, that is the second derivative, kid. Because the first derivative was bringing down the 2 and making f prime. So that is the first derivative. And the second derivative was going one more time. And then plugging in your 3, and then putting in your clues. Is that cool? You'd have 2 times f prime squared, and f prime of 3 is 5, plus f2 times f double prime. So you have 25 minus, negative 2. 25 minus 4 is 21, times 2 is 42. Right? Yeah, but sorry, that looks like a second derivative, but it's not. That would have been, I don't even know how you would have done that. You couldn't have, sorry, that's the long story short. Without a function, like, I don't know how you would do that. What else you guys got? 43 to 45. Let's not talk about 45 again, if you don't mind. Anything 43, 44? Some of you guys have had time to fully think through all of your corrections. Some of you guys, it's just overwhelming and you did the best you could. Turn in what you got. Hopefully it has, except for the couple that were absent. You can turn it in by the end of the day if you want to work on it a little bit more. Those of you for whom it's due today. I want you to attempt in grading, but that doesn't mean that you ace this. Like, it doesn't mean you totally understand it. So feel free to come on in anytime this semester if you want to talk about it more. Totally cool. But for right now, let's go play with something new. Notes open, trig sub. Nice. No way this worksheet tomorrow. It'll be due on Monday. Which a couple of you guys might want to check out a trig sub video over the weekend. Here's something for you to keep in mind. It doesn't need to be mastered. This is something a college class would teach you, but it's not on the AP itself. At least, if it is there, there must be another way of doing it. It's not on the AP itself. If it is there, there must be another way of doing it. Sorry, my screen blanked out. The question is, P.S. Chapter 9, if you guys want to check it out, there's the title. Sequences, L'Hopital's, and improper integrals. Chapter 9, yeah. Trig sub is not technically in Chapter 9. So I'm calling it an aside. I think it's somewhere. I think it's somewhere in our book, but I think we skipped it whenever it did show up, or it's in a random extra place. But any college Calc 2 class would teach trig sub. The most recent one I saw was, that I tutored, was Moore Park. Their there was an whole. Oh no. Kids that came up from UCSD were talking about their calc class. I did calc 3 and had to do trig sub. So it's a thing. Just our AP force it. But if you guys notice, chapter 9 is not going to be too bad. It's kind of just finishing up a few things from first semester. Still important, but it's not going to be too bad. Chapter 10 is where the bulk of our new content for the entire year is going to happen. But in some ways it might be nice for some of you because it's something brand new that everyone's starting off at the exact same place on. Trig sub. What is weird about these expressions if you see them in an integral? Two different levels. We know a's and u's, don't we? Aren't u's variables and a's constants? Like with inverse trig? But the problem, is this a 1 over? If it was a 1 over, ooh, what would it be? Arc sine. If it was a 1 over with a u, it would be arc secant. And if it was, I don't know what that is. So in integrals, these are actually kind of unfamiliar. Wait, no, they're not. At least one of them's not. Why am I going to rewrite it? R is a constant just like A is a constant. Why did I just change the letter? You guys said it yesterday. You don't like it. Who is this guy? Who is this guy? It's a semicircle with a radius of r. Now technically we're used to r minus x squared. That's true. R squared minus x squared, but it's a semicircle, remember? Because a circle is x squared plus y squared is equal to r squared, and we could change the x to be a u expression. But remember, y equals the square root of r squared minus x squared is just a semicircle. So if you ever see him in an integral, what are you supposed to use to solve? Geometry. How much geometry? Well, I don't know. Are they asking for semi, 1/2 pi r squared? Are they asking for a quarter? Are they asking for... I don't know. But he's just a semicircle. So somehow we're going to be using 1/2 pi r squared probably, or something. If the bounds are from like negative r to r. So we can deal with him, but how about... Some of you might remember and some of you might not. Back when we did in both last year and this year, I used triangles. And we're going to again. Because with this expression, yes, it's an algebraic expression, but it could also be a right triangle, solving for maybe a hypotenuse. This one could be a layout of a right triangle, Pythagorean theorem, solving for a leg. And this one could be a layout for a right triangle, solving for a leg. There is a strategy as to what you put where, because if you guys realize I could have put these either leg, I could have put this either leg. I could have put this either leg. It just had to be a leg. But in essence, actually, all of these somehow are coming back to the Pythagorean theorem, or some rearrangement of the Pythagorean theorem. But how on earth does that help? With trig substitution, we can take algebraic expressions, relate them in a right triangle, and change those algebraic expressions to trigonometric expressions with a d theta. And with trig, don't we have a lot of t-proof stuff that we can change things around? So maybe what we can't change algebraically, we can't move a square root across a plus or across a minus or across a minus. We'd have to factor, and it's impossible. We couldn't algebraically do anything. But trigonometrically, maybe we could. Well, the problem is an a plus u and an a minus u doesn't have a square root. Struggle, huh? Killing puppies. So let's take this guy. How would you integrate him? Not arctangent, he has a square root. Not arcsine or arcsecant, doesn't have a minus and doesn't have a minus. So what could we do? What if we were to see that this could have come from the square of a side, and that could have come from a square of a side, and this could have been the hypotenuse? Pause. Doesn't a squared plus b squared square rooted become the hypotenuse? Isn't that expression the same thing as the hypotenuse? So couldn't I say in some way, shape, or form, of the ways that might make more sense, couldn't I set up some sort of expression like hypotenuse over adjacent? Is that secant? Couldn't I say that secant of theta is equal to that expression that I see down there? Now you might be like, okay, but we also have a dx. Like I could change this, and if I did change I can't go integrating if I have a theta and if I have an x, so what would I have to do? Derive both sides. Ah, gross. Okay, pause. Maybe we don't want to go straight for the expression. Maybe we wanted to go for something easier first. Like, what would be a lot easier than secant? Isn't tangent just 2x? Ah, that would be a lot easier to derive. I could say secant squared of theta d theta is equal to 2 dx. Could I go ahead and come over here? And even though I'm not able to strictly take out the algebraic and put in the trigonometric, I could take out the dx and make it secant squared theta all over 2 d theta, and then I could plug in the tangent for, well, tangent's 2x, lo siento. I could take out the x and I could plug in tangent over 2. Now some of you are like, well, that just made everything worse. But did it? I substituted for the x using a trig expression. I substituted for the dx using a trig expression, and this is disgusting. Well, maybe it's not, because wouldn't you end up pulling out whatever the 1/2? I'd end up with secant squared theta all over. The 4 ends up canceling with the 4. Tangent squared theta plus 1 is secant squared. Is this an integral that I can solve? Yeah, because who's the square root of secant squared? Secant. What's secant squared over secant? Secant. And what's the integral of secant? You're done! Well, technically you'd have to come back here and say, hold on, who's secant again? Hypotenuse over. Who's tangent again? And then we get a nasty answer to an integral that there is no way algebraically we could have done. Otherwise, bye, cool kids. I'll see you tomorrow. If I were you, don't start homework tonight. Maybe watch a trig sub video, but I'm not so sure this is exactly enough to get going on it. Was your mind blown?
Yeah.
You're welcome. Love you all. See you later.
I was like following after the triangle. I'm like, oh, this is so easy. I know, right? Okay.
And you do.
Data, and then you're like,
I know.
Well, then I simplified. Sorry, following. So I went. But that'd be over 4. The 4 is reduced. Tangent squared theta plus 1 is a Pythagorean equals secant squared. That one becomes secant, and then that divides to be just secant. And the integral of secant is ln of secant plus tangent. And then I go find it, and then I plug it in. What? Don't worry, it's not on the AP. We'll just play with it a little bit more tomorrow.
But I would never, ever do that in my wildest
like,
dreams.
oh, squared.
Which is why it's so crazy.
Let me like go secant. Okay, I'm just gonna.
X is for trig.
Half.
No, but let me go tangent and then use the derivative to go back to it.
It's u sub, but with thetas.
No, like I mean, not a different tangent.
Oh, man. Bye, guys.